My name is Mohammed Arsalan and I am making this video for postdoctoral fellowship of NASA at the University of Maine regarding real-time wireless shape monitoring of the space structures. I will answer my questions with the help of this presentation. Going towards question number 1. NASA is using these inflatable structures in the space or for making antennas or large space bodies because of the obvious advantages of cost, space, and lightweight. The problem in its harsh space environment is the temperature variations could be hundreds of degrees centigrade in day or night, or in the presence of cosmic rays and collision of small micrometeoroids. It is essential and critical to monitor the shape of these structures. Wireless shape monitoring is an effort towards that. Now, the major challenges to make such a system are, first of all, the sensors. No sensors in these days are available to do this task along with a wireless module or in wireless fashion. So we need to make sensors that can withstand that harsh environment and can work in it and can also work in conjunction with the wireless circuitry and can transmit their data wirelessly, and most preferably in non-battery like fashion, like battery-less system. On wireless side, we need to build or make use of existing state-of-the-art protocols so that we can communicate with more than one sensors at a time, or can identify the location and the value of each sensor individually, and the sensors should be robust enough to work in a high EMI or electromagnetic interference environment, and they should not fail like the recent incident last week of the NASA astronauts when they went out for a spacewalk. Their mics stopped working because of the high static. The final and last but not least is the miniaturized size, lightweight, and extremely low power requirements that are the prime concerns for any space application because of the limited supply of power. When this structure will be fully developed, it can be implemented for civil structures like bridges and other tall buildings for routine monitoring or after an earthquake or aftershocks. Obviously, this is a multidisciplinary huge project. Not a single person can have the abilities or the specialties to exactly fit in all of those areas. So, in the list of all those 5 areas that are identified in the proposal, I feel that I am a strong candidate in sensor design because of my previous experience on radiation sensors and other microelectronic sensors. System integration, I have proven track record of integrating the whole wireless vital signs monitoring system in package and system on package application using LTCC module, which are very applicable for space applications and very robust. And signal processing, I have a good background of mixed signal, analog and RF backend circuitry and front-end too. The weak link, however, is the coding theory and structural monitoring, which is, of course, not my area of expertise. However, to fill this niche and this gap, I am planning to utilize the other graduate students that are part of this project, maybe masters or doctoral students, depending on the amount of work required. The most significant contribution that I have yet is the development of world's first wireless dosimeter or wireless radiation monitoring for radiotherapy applications. It's a full working system, first of its kind. It has a transmitter chip, a sensor chip with many sensors and a battery, and it's a full working system. The size is very small, smaller than a dime, and the good thing is this system is as applicable in space to monitor the radiation exposure of the astronauts as in the radiotherapy. This project has given us many awards and distinctions and scholarships. Some of those are the CMC Texco Award, Canadian Microelectronics in 2007, and OCRI Researcher of the Year Award. OCRI is Ottawa Center for Research and Innovation in 2008. The supervision capabilities, I was involved in this collaborative project for my PhD wireless vital sign monitoring system, It has two main researchers, myself and my fellow Adib Shamim, 3 supervisors, 2 industry partners, and several other service providers. So it's a natural fit for me to work in such environment. Also, while working in industry as an instrumentation engineer, I was supervising more than 25 technicians to do everyday jobs, and especially in turnaround time, major tasks of new instrumentation implementation and other stuff. So I feel it natural, and I am very willing and able to supervise a group of candidates to accomplish any task. As far as the question of availability, I am available immediately for any right opportunity. My long-term goals are to work in academia as a professor with a specialty in wireless sensors using unique new materials. And to satisfy my entrepreneurial nature, I'm a strong believer of bringing industry-academia partnership together to produce a meaningful and practical research. Thank you very much.